Okay, now I want to find all the possible rational zeros from this polynomial. And then after we find all the possible rational zeros, I want to find all the zeros that truly do make up this polynomial. So kind of put in parentheses here that we should have 4 zeros because it is a 4th degree polynomial. So first thing that we're going to do is we're going to list the possible rational zeros. And again, that comes from finding our factors of our first term and the factors of our constant term, which are 1 and 18, 2 and 9, and 3 and 6. And again, we're going to take all of these and divide it by these over here. So we're going to get plus or minus 1 divided by 1, which is 1, plus or minus 1 divided by 2, which is a half. Done with that one. We'll go on. 2 divided by 1, that is 2. And 2 divided by 2 is 1 again. Next we'll go to 3. 3 divided by 1 is 3. And 3 divided by 2 is 3 halves. 6 divided by 1 is going to get us 6. And then 6 divided by 2 is 3 again. 1 to 9. 9 divided by 1 is 9. And then 9 divided by 2 will get us 9 halves. And finally, 8 divided by 1 is 18. And then 8 divided by 2 is 9. So again, this long list, this represents our possible rational zeros. Okay, so now, how do we find the actual zeros from this list? I'm going to give you a hint. There are 2 of them. And the best way to do this is to really just kind of guess and check. If I would take, for example, positive 1 and plug it in for all these x's, and I get a value of 0 out of it, that would represent a 0 of the polynomial. But if I get some other number, then I know that it's not a 0. Okay, and the 2 zeros, I'm going to tell you which ones they are. The 2 zeros that we get out of this are plus a half and a positive 2. But again, the only way to come up with those is to guess and check. So if you plug in the value of, say, 2 into this polynomial, out comes a 0. So we're going to say 2 of the zeros right now are x equals 2 and x equals a half. And now we've got to come up with the other 2 zeros. And again, we're going to do this by synthetic division. So I'm going to start with 2. You can start with either one. Put 2 in the box and write down all my coefficients from our polynomial. 2, negative 5, 20, negative 45, and 18. And here we go. 2, drop it down. 2 times 2 is going to get us 4. This will get us a negative 1, negative 2, which will then get us 18. 2 times 18 is going to get us 36, which will then get us negative 9, negative 18, and 0. And we're going to do synthetic division again with the value of a half with these same values. Again, drop the 2. 2 times a half, that's 1. Add, that's 0. 0, add, that's 18. 18 times a half, that gets us 9. Now we broke down our polynomial. So I want to take our zeros, and we're going to write them as factors. So if we say one of the zeros is x equals 2, the factor of this would be then x minus 2, because I would subtract 2 over to get it equal to 0. For the x equals a half, we have to do a couple steps. I'm going to subtract it over first. It's us x minus a half equal to 0. Again, a factor does not have a fraction in it, so I'm going to multiply this whole thing by 2. We multiply by 2, and we have 2 times x, which is 2x, and 2 times negative a half is minus 1. And then after we pulled out those 2 factors from our synthetic division, we were left with a 2x squared plus 18. This is known as the factored form of the polynomial. Standard form is what we started with, way up here at the top. This up here is standard form. We just rewrote the polynomial in factored form, which helps us find all the zeros. The first two, we already found those from our rational zero theorem. But now we got to find the zeros from this last portion here, 2x squared plus 18. So we're going to set that equal to 0. And we're going to solve it. So to do this, we're going to subtract 18, which will then get us a 2x squared equals negative 18. Divide by 2, x squared equals negative 9. To solve for x, we're going to take the square root. X equals the square root of negative 9, which is the same thing as plus or minus 3i. So from this, we have 4 zeros. We said at the very beginning with our possible rational zeros that two of our zeros were x equals 2 and x equals a half. And then from our synthetic division, when we broke it all down, we had another zero of 3i and negative 3i. And there is all of our zeros to this polynomial.